Everyone, my name is Bharat Raj, and in this presentation, I'll take you through my approach to predicting wine quality and using data analysis and aggregation models as part of SIT 718 Assignment 2. On the second slide, the overview. The main objective of this task was to predict wine quality using selected chemical properties, and I built and compared models like weighted arithmetic mean, weighted par mean, and ordered weighted averaging. On the third slide, the dataset includes 1,599 red wine samples from Portugal. Each sample contains results for physico-chemical test and quality score assigned by tasters. And on the fourth slide, the variable description. For this project, I focused on four key input features: citric acid, chlorides, pH, and alcohol. The quality score is a target value we aim to predict. On the fifth slide, sample selection. I selected 460 random samples from the data set using my student ID as a seed to ensure the sample is representable and statistically fair. And on the sixth slide, as you can see, the histogram. By plotting a histogram, I noticed the citric acid and chlorides were right skewed, and pH was slightly skewed to the left, and alcohol was fairly normal distribution. And on the next slide, for the scatter plots. Scatter plot shows a visible positive relationship between alcohol and wine quality. The other variables had weaker or lesser clear patterns, as you can see in the graphs. And on the next slide, the transformation to handle skewness and to ensure model accuracy, I transformed each variable appropriately before feeding them into models. On the ninth slide, the transformation details. I applied a square root transformation to citric acid, log to chloride, squared the pH values, and left alcohol unchanged. The quality score Y was normalized afterwards. And on the next slide, normalization. After transformation, I used a min and max normalization to scale each variables between 0 and 1. This helps aggregation function to compare input inputs fairly and consistently. And the next slide, model review. I tested four models like WAM, WPM, and OWA. And WM calculates the weighted average of normalized values. WPM adjusts sensitivity with different power values. For example, in this we have used P is equals to 0.5 and P is equals to 2. And for OWA, sort the weights of inputs by magnitude instead of the original order. Each method provides a unique perspective on predictions. And the next slide for the model performance table. This table compares the four model based on an error and correlation. WAM had a RMSE of 0.172, as you can see in the table, and pronounced correlations of 0.30, simple and easy to understand. WPM with a P equals 0.5 uh, gave a slightly higher error, while P equals to 2 emphasizes larger values, as you can see the table. OWA gave the best overall result with an RMSE of 0.17159 and highest correlation of 0.45. And on the next slide, as we can see the weighted tables. Here I'm showing the weighted for the best performing model. In WAM, the weights were 0.136 and for citric acid, and 0.518 for chloride, and 0 for pH, and 0.346 for alcohol. This confirms that alcohol and chlorides are most influential in determining wine quality, while pH didn't contribute to the predictions. And on the next slide, for the variable important discussion, from the weights, the alcohol clearly had the strongest influence, followed by chloride. Citric acid also contributed slightly, and pH had no impact under WAM. And on the next slide, the best model choice. Although OWA had the best performance metrics, I used WAM model for the prediction because it had more transparent and easier to explain, especially for real world like decision making. On the next slide, for the new input predictions, I used input values x1 is equals to 0.8 and x2 is equals to 0.63, x4 is equals to 2.51 and x5 is equals to 7. After applying the same transformation and normalization, I predicted that wine quality using the WM model. And on the next slide, is the prediction reasonable? The WM model gave a second scale prediction of 2.303, while the score may seem low on the normalized scale, but it makes sense given the higher weight on the chlorides and moderates alcohol in the input. And on the next slide, best condition for high quality. To produce higher quality wine, the model actually suggests maximizing alcohol content, keeping chloride low, maintaining a balanced pH, and including some citric acid for freshness. And for ethics and data privacy, even though the model is helpful, I mean, for the wine quality is still subjective. It's important to be actually transparent about model limitations and to ensure ethical handling for any data, especially if the customer data is used. And to wrap up this, I built a WM model to predict wine quality using four input features: transformation and normalization, improved accuracy, and alcohol and chlorides had the biggest impact. Although OWA performed the best statistically, WAM offered clear and interpretable results. In future works, I would explore using more features or hybrid models for greater precision. Thank you.